All right, we're on lesson 3 of our textbook. This would be day 3 of our school year if we started with this textbook right away. Over the last 2 days, you probably are getting a little frustrated saying, man, they're asking me to do a lot of thinking here and problem solving that I'm not used to. These warm-ups are pretty tough, but I noticed too that in about a week they get a little bit easier. But you gotta practice, okay? Here we go. Warm up. Some friends want to see a movie that's showing at 2 different theaters in town. They plan on sharing 3 tubs of popcorn during the movie. So they don't really say how many friends, but they do say that they're going to share 3 tubs of popcorn. So you're kind of committed to the popcorn there. And so what they really want you to do on this one is take 3 times this amount of popcorn, because no matter what, that's one of the rules up here. They're just going to share 3 buckets of popcorn, but you really don't know how many friends there are going to the thing. And so, which movie theater should the friends choose? You can just make up a number. Make up the number of friends that you want to go to the movie so that we can compare them. So, plug in some number there. That if I had 5 friends going to the movie, well, each one's going to pay $14.50 for a ticket, plus whatever the popcorn is. That one's committed. And the same 5 friends, if they go to theater B, okay. So what they want you to do is kind of just come up with some numbers. They don't really say that here, but that's what sometimes we have to do, is pick a number and just plug it in. For which situation would the cost of the theater be exactly the same? They want to start in the right equations now, equal to each other, like you did at the end of the last year. Okay? And there are different methods to solving this problem. Which one do you think is best and why? So this one's going to take you a little bit of time, so pause your video. I know that's kind of frustrating because you know the answer's on the next page and you just want this to be done. But I really, really would like for you to try, and even if you're struggling a little bit, sometimes struggling is okay. Alright, let's see how you did. I happened to pick 3 friends going to the movie. And so what I did is I took 3 times the $14.50. I don't really need the zero behind it. And 3 times the $5.75 for the popcorn. So then I added all those guys up and did the math, and I got $60.75. Same 3 people going to movie B, $13 a ticket. Their popcorn was a little more expensive, but the ticket was a little bit cheaper, and I got $59.25. So if 3 people go, B would be cheaper. Okay. For which situation would the total cost of the theater be exactly the same? Now this is where we don't know how many friends, so I'm going to put a variable here. I said let's F be friends. I do know they're going to pay $14.50 each, and I do know they're going to pay $3 3 times $5.75 for the popcorn. I want to know when they're going to be the same. So I went to movie theater B. I don't know how many friends are going. That's what I want to know. So I have $13 times the number of friends, 3 times the $6.75 for popcorn. And so writing an expression or equation like this is going to be very helpful. Alright, so I want to get my F by itself, which we practiced this last week. Got to get that multiplication out of the way. Got to get that multiplication out of the way. I decided to get this 1725 over here, but you could have said let's get this 20 over here. I like to kind of just keep my F's on the left side here. So after I had that, I kind of ran out of room down here, so I brought my $14.50 F down. There's my $13 F, and this was 3. So I ran out of room, so I rewrote it up here so I had some more room. If I got my numbers over here, well then that means I want to get my F's over here. So I subtracted $13 F's. I came up with 1.5 F's equals 3. I divided both sides by 1.5 to get the F by itself, and I got 2. So now I'm going to come over here and say 2 friends, they will cost the same. There are 2 different methods. Up here I just did some guessing and checking. Here I wrote an equation. In my opinion, I like the guessing. I got the answer faster. Okay, so this one's kind of open to whatever your opinion is. I probably would have guessed and say, hey, you know what, that's pretty close. Let's guess 2 friends up here instead of writing an equation. Okay, so depending on how close you are, writing an equation might not be the easiest. Okay, all right, so practice this writing equations here. It's expected that we're able to do that by now, okay? And we get a lot of word problems, so let's keep practicing. Don't give up. All right, so today we want to be able to write and solve equations with a variable on both sides and solve those problems. All right, vocabulary is identity. This is just some examples for us to kind of look at and think about. That if we had this math problem called 2 times x plus 3, there's my x plus 3, there's my x plus 3, and I have 2 of them. Okay? On the other side of the equal sign, it says 3 x's. Well, there they are, plus 2, plus another x. And so what we're going to do is we're going to collect like terms here. They're going to put those x's with those x's and say, you know what, I have 4 x's here, plus 2. There's the plus 2. I don't like the way they write this. Really, I should say 4x plus 2. Over here, I put these x's with these x's. So I got 2x. But I really have 6 tiles, so what they did is they did distribute 2x, or 2 times x is 2x, and 2 times 3 is 6. Now, what they're trying to do is they're going 2 steps at one time. They're trying to get these 2 x's onto this side, or cancel out these 2 x's and 2 x's there. Cancel out 2 units there, 2 units there. So what are they left with on this side? They just have 4. There they are. On this side we have 2x, and that's it. 2x is right there. So then they said, well, I want to know what 1x is. So they divided by 2, because they want 1x, and x is 2. It's kind of confusing, but now you kind of have a visual of what we're doing. X's are bigger than units. So let's go over here and solve it mathematically without the algebra tiles. So as I look at this problem, I see that I have parentheses here, but no work to do. And I know multiplication and division is right after exponents, so I'm going to do this guy. Let's do 2x plus 6. Now on this side, I'm looking and it says, hey, I got like terms right there. I got 3 x's there, 1 x there for a total of 4x. So let's put that together. So we really kind of did 2 steps at one time there. Now you got to decide what side you want to get the x's on. Again, sometimes kids like to keep their x's positive and plan. And so if I minus 2 x's from both sides, then these guys cancel out. I got 6 equals 2x plus 2. Now that I got these x's over here, I want this 2 over there, so I minus 2 from both sides. So now I got 4 equals 2x, very similar to here, 4 equals 2x. And now lastly, I want to divide by 2, because I want to get the x by itself. I want to put my answer in standard form. X comes first, and 4 divided by 2 is 2. Now, before we go too far, up here, I want to rewrite this. 2x, you can just watch, equals 4x plus 2. There are 4 different ways that I can start solving this problem. I can put this 6 over here, or I can put this 2 over here. I could put this 4, so I want to put the 4 over here, because a lot of times kids say, you know what, I want the x always on the left-hand side. So let's do that. We still should come up with the same answer if we do order of operation. So, we've got the x's over here. Now that I have the x's here, I want that 6 over there, so I want to subtract 4. Now I got minus 2x equals minus 2. And now the last step, I want to divide by a negative 2. Divide by a negative 2, and I still get negative divided by negative. Uh-oh. What happened here? I should get the same answer. I'm getting negative 1. Let's see what happened here. Did I copy the problem right? You're probably yelling at me. So I subtracted 4 x's. Yeah. Brought my 6 down. Brought my 2 down. Oh, here's where my problem is. Where'd that 4 come from? Good Lord. I don't know where that 4 came from. Let's see. I just need a different color. I needed to subtract 6 from both sides. So now I got minus 2x. Oh, I know. I was doing some math in my head here. Be ahead of time. So equals negative 4. And now I'm going to divide by -2, divide by -2, and x equals 2, just like we had over here. Negative divided by negative is positive. Alright, so I don't know. I was doing math in my head 4, and I put the 4 right there. Alright, so lots of ways to solve it. So your work might not look exactly like mine when I show my work up there, but we should be able to walk the steps through. Now, this is a very good practice, and I try to teach this kids in algebra, because they don't do it in junior high. And so as we're going along, if you hate fractions, what you can do is you can multiply, and this is what they did. I see a denominator of 5, and so rather than, and this is one term, by the way, instead of finding a common denominator all the way across, you can multiply this whole guy by 5. Because 5 over 1, that would be 5/5, which is 1. So these guys cancel out. But what you have to remember is, and I write it up here, you have to do every term by 5. Okay? So really, this 1/5, that fraction goes away. So it's 1 times n minus 6, which is still n minus 6. 5 times -7 is -35, and 5 times 9 is 45. And so that got rid of my fraction. We have a calculator, so it's not that big of a deal to do 1/5 times n, which would be 1/5 n, and 1/5 times 6, and get a decimal there. So it's not that big of a deal. So as we're moving on here, though, we still end up with a fraction answer here. And that's an improper fraction, so that's not okay. 12 goes into 17 one time, there's 5 left over, and there's still 12s. So as a mixed number, don't leave your answer as an improper fraction unless the directions on your homework say leave it as a fraction improper. Not sure why they would, especially in 9th grade. Okay? Alright, so here's a couple for you to do. So pause your video. Let's see how we do on these. You can see that they're getting pretty intense now. We got lots of decimals and lots of operations. Pause your video and then come back when you're done. Let's see how you did. Alright, let's see how you did. Now, everybody should have this line exactly like it is, because there is nothing there. But now you have lots of options, 4 different options on what you did from here. Again, I like to get my z's over to the left. So that's what I did, is I added 40 z's, or 50 z's, sorry. Got all this, got my 20 over to this side, divided by 150, and got a decimal answer. A lot of times in life now, you'll get decimal answers. Junior high, you probably had whole numbers as for answers. Alright, so don't sweat it. On this guy, I didn't really need the parentheses. Nothing happened in there. There's no work in the parentheses I can do, so I just brought it down. But I have to do the distributor property here. Then I saw like terms. Then I decided on this problem to get that 24 over to this side first. Then I decided to get the 6 D's over here. And then my last step is, let's divide both sides by 10. This is very important that we're able to do this, and do this kind of fairly effortlessly. That is kind of just natural. So this is what I was talking about a week ago, when some kids were not, they're just putting the whole thing in the calculator and hitting enter. Well, you can't no more. We got D's up here. You don't have D's on the calculator. And so last week when I said, hey, you don't show any work when we were doing those problems without a variable and doing order of operation, and I said if you don't have any work, it's just wrong. This is why. You need to know how to be able to do this and fast and efficient. Okay? Alright, you struggling with this, get some help, because this is what we do all year long for the rest of your math career. Alright, let's check out this guy. So again, if you want to look at these algebra tiles, sometimes kids need this visual over here to be able to do it. And so basically they're just saying, hey, you know what, that 4x plus 6, we're just going to bring it down. There's no work there. But then they took 2 times 2 x's and they got the 4 x's and put them together. And then 2 times 3, which is 6 of them. I have 2 sets of 3. So all they did is collect like terms. Let's go over here and do this guy over here. That 4x plus 6 has nothing to do, so I'm just going to bring them down so I keep track of all my work. But I do have to do the distributed property over here. So that's going to be 4x. And I have to do 2 times 3, which is a plus 6. Now, sometimes it's nice to start as you're in algebra to start working with your x's, because watch what happens here if I do minus 4x. Kids panic here. Oh no, my x's went away. I got a 6 on this side, and I got a 6 on this side. So this is what we call the identity. If this is true, when our x's go away, if what's left is true, then on this one we say all our infinity solutions are all, let's see, what is it? I'm trying to remember. All real numbers, I think, is what they put on. Let's see. No, infinite solutions. Now, sometimes kids do this, so I want to show this. I'm just going to take this problem here, say 4x plus 6 equals 4x plus 6. Now, sometimes kids don't work with their x's first and said, you know what, I'm going to get the 6's away. And so now they go away. Now I got 4x equals 4x. And you say, well, I want to get my x's on one side, so if you minus 4x on both sides, now they cancel on this side, you got nothing, and on this side they got nothing. So that's still true, 0 equals true. 0 equals 0. So that's still true. And we would still write infinite solutions, okay? So that infinite means you could plug any number, any fraction, any number in for this. And what you plug in on this side, let's say it was a 2, that'd be 8. 8 plus 6, that's 14. If I plugged in a 2, 2 times 2 is 4. 4 plus 3 is 7, and 7 times 2 is 14 too. I can pick any number, any fraction. That's what infinite solutions means, okay? All right. So now let's check out this guy. Let's see what happens here. They did this one for us, I believe. I don't think we have any work to do. So they started this. They took this times this times this. Then they said, well, let's subtract 6x's from both sides. I like showing it this way. I think they're committed in a computer to kind of do it on one line, so I don't like that. So let's just draw a line through that. Your x's go away, your x's go away, and you have minus 5, and here you have an 8. Well, that's not true. So we usually put a slash through the equal sign, and on this one, we're going to write no solution. There is no number that we can put in to that math problem for x that would be the same amount on this side as the same amount as this side, okay? So 2 problems today now when our x's go away. If everything comes out and it's not true, then it's no solution. If it is true, if this was an 8 equals 8, then it would be infinite solutions, okay? All right, I think you got 2 here to give a shot. Do these 2 guys, and let's see how we did. Put your answer, well, if you were in class, you'd put your answer for A on the whiteboard. All right, let's see how you did here. Let's see, this is really a -1 times 27 right here, and -1 times t, so it's just the opposite signs of whatever's in the parentheses. I decided to get my t's over here. My t's went away right away, and I had -27 equals -27, so that's going to be infinite solutions. Over here, you could have gotten rid of, no, I wouldn't even do that. Never mind. Got to get rid of the parentheses. 96 times, there's really a 1 in front of that m, so that would be -96m over 2. And 96 times 1 is 96. I reduced this guy. -96 divided by 2 is really 48 m's. So now, here's my 4. I brought everything straight down. So I added 48 m's to both sides, and my 48's went away. And I got 64 equals 96. Well, that's not true. So that would be a no solution. Okay? Alright, here comes our word problems. It is very beneficial sometimes to make a table. Now, they made the table for us, but we got to keep our information kind of organized. And so if they didn't make this table for us, I would be making one, okay? All right, so here's what the deal is. They're going to have 2 kinds of coffee here. It says Arabic coffee costs $28 a pound. So I'm going to put the coffees over here, the prices, how much we bought, and what's the total cost. Okay? Because that's going to help me organize my information. So again, a lot of times kids will say, well, that's too much work. I just want you to write me the equation and write I'll solve the equation. Well, in real world, that's not how things work. So I started filling some things in. Arabic is 28 bucks a pound, and Robusta coffee is $8.75 a pound. How many pounds of Arabic coffee must you mix with 3 pounds? So I bought 3 pounds. I don't know how many pounds of Arabic coffee I'm buying, so I'm going to put a letter there. A for Arabic coffee. How much 3 pounds to make a blend? So I want to make a blend. Here's my 2 copies. I want the total to be $15.50 a pound. Okay, so now I kind of filled in all my charts here. This plus this has to be, cost of the blend has to be $15.50. So now I don't know how many Arabic, but I do know how many Robusta coffee, 3 pounds. So when I write this, since I don't know, I know this needs to be the total amount of coffee right here. However much Arabic plus this guy. Okay, so now that helps me down here because look at, when I write this, it has to be at $15.50 a pound. I don't know how much Arabic coffee I'm buying, but I do know how much Robusta I'm buying, 3 pounds. So here's my total going across this way. Okay, so that's what they have here on one side of our equal sign. $15.50 plus the amount of Arabic coffee plus 3 pounds of this. And now they said, well, you know what? The Arabic coffee is going to be $28 a pound. I don't know how much. There it is. I do know Robusta coffee, it was $8.75, and it was 3 pounds that I bought, and so there's my total there. And so on the other side, I'm going to do this. 28A plus the 2625 has to equal what this guy is. So we're kind of merging right here. Okay? So there now is my equation. So having good notes also will help you when you go to do your homework. I was helping some geometry kids last week and they were taking a quiz and it's like, wow, this is good algebra here. I said, but somewhere in your day you should have taken some notes of the 2 angles put together have to equal this, and they said, no, we didn't do that in class. And I looked at another girl's notes, and sure enough, they did do a problem just like that one that was on the quiz. So, taking good notes during this time. And again, some practicing here. When we do it 2 or 3 times, you'll start to be able to get these charts down. So, don't give up. So I did all the math over here, or they did all the math, and they got 1.62. So then they answered the question. You must mix 1.62 Arabic coffee with 3 pounds of Robusta coffee to make a blend that costs $15.50. That's what the question says up here. Okay? So now, let's do some filling in this chart. I kind of gave you some blanks here, but let's use that example right up above to kind of show what we're doing here. Alright, so here's the total prices right here in the coffee blend. It said, how many pounds of Arabic coffee should you mix with 5 pounds of Robusta coffee to make a blend that costs $12 a pound? Well, they said we want $12. So if you look up above, when we did 12, that's where that guy goes. Now, the Robusta coffee, they told you how many pounds. It's 5 pounds. Okay, so now we got A plus 5. We don't know how much of this, but we already have 5 pounds of that coffee, so that 5 goes right there. And now, let's do this guy. I want a total over here. 875 times 5. Do that on your calculator real quick. What are you getting? 4375, I believe. Okay, so now, how did we get this guy here? All right. We took this guy, 12, times this guy, A plus 5, and so that goes there. So this and this has to equal this. Okay, so now let's go over and write our equation over here. We got 28A plus the 4375 has to equal this amount, okay? This cost plus this cost has to equal this. All right, got you started. Go to work. Get that A by itself and then answer the question fully, because A is going to be the amount of Arabic coffee. All right, pause your video. Let's see if we get the same answer. All right, here we go. Yep, I put all the numbers in the right place. Now, you had to do a little rounding down here, which we didn't talk about rounding yet. Most of the time we round to the hundreds. This is tenths, this is hundreds. So, there's a 5 next door. We said if the number next door is 5 or more, that number goes up 1. Okay? So, I said 1.02 pounds of Arabic coffee. You would need 1.02 pounds of Arabic coffee to make a blend that costs $12. Okay? Alright. Let's see, yep, that's what they asked. How many pounds of Arabic coffee? Alright, I was thinking it was Robusta, but it is Arabic. Alright, take some practice. Hang in there. But look at, we're not focusing on how to do the steps of PEMDAS anymore. We're focusing on how do you write the equations. Alright, this comes up all the time. This guy is going to pay 95 cents per song for his current music service. You guys download music all the time. But another music person says, hey, you know what, we only charge 89 cents per song, but you have to pay 12 bucks to join our club. So when should Cameron switch to the new service? So we want to know, when is it going to be a good deal? If he's only going to buy 1 or 2 songs, well, this is the best deal, because then I don't have to pay this $12 fee. So I want to know, when is it best to go with a new plan to pay that 12 bucks? So again, we just want to set 2 equations equal to each other. So the first guy, we don't know how many songs he's going to buy, but I like that they put S for songs there. Okay, so the new music service, I guess they're going with this guy, is 89 cents a song plus the 12 bucks you have to pay one-time fee. The other guy is just 95 cents a song. So let's go down here and compute this guy real quick. Let's see, let's get this 89 cents S's over there. So let's minus 0.89 S's. Minus 0.89 S's. And now we got 12 equals 95 take away 89. I'm getting 0.06 S. I want the S by itself, so I want to divide by 0.06. 12 divided by 0.06 equals 200. So, what I say, does this guy have a name? Yep, Cameron should go with the new plan if he has 200 songs, he's not saving any money, because 200 songs are the same. So you need to say new plan if he downloads more than 200 songs. So at 201, he's starting to save money now. Okay? So, that's very important. 200, he's going to say, I didn't save no money. It's the exact same thing. But at 201, 202, 203, he would be worth his while to join the new plan. Okay? So, a lot of times, we'll start doing this. These are the examples that are in the textbook. And we got to do a little bit of work. And then now they just give us more, or I should say less help, more work to do. So, Cameron's friend tells him another service that he has joins $15 joining fee, but charges 80 cents a song. So it's very similar to the example up here. Up here, though, it was 89 cents and $12. This guy stays the same. So you can use this example over here to kind of model after, and then write it, and then solve that math problem. Okay, so pause your video, give it a shot. Some kids are just going to sit in my classroom saying, this is too hard, I can't do this. Now's the time to give it a shot. We can make mistakes. This is our homework. Okay, but we want to make sure we work it out by the time a quiz or test comes along. All right, let's see how you did. So now it's 80 cents a song plus the $15 to join. And the other guy, I think it was 95 cents. Yeah, he's 95 cents. You have it on your paper there. You can see I have to keep scrolling up. All right. So in that case, 100 songs. He needs to do more than 100 songs if he, I forgot an L, SHOULD. Then he should switch to the new plan. All right. All right. Check that out. Here's our summary. You know, it's, let's see. I'm not sure why they're doing all this dimensional analysis stuff, but here's what we want. We want one person's distance equal to the other. So this is kind of the deal today. Is we figure out one person's equation and then the other person's equation, and then we solve it by getting the h by itself. Okay? All right, setting two equations on two equal to each other, and then get that variable by itself. All right. We'll do the homework online. Don't forget that you're doing the one that doesn't say Savvy. Most people, unless you have special conditions, okay, you only do one, not both. All right, have a good day.